Nathan is trying to hit a bottle with a ball. The bottle is standing on a narrow wall 12 metres away from him. The bottle is 20 centimetres tall and its base is 3 metres above the ground, which is level. Nathan throws the ball up the bottle with a speed of 12 metres per second at an angle of 42 degrees above the horizontal. The point of projection is 1.2 metres above the ground. Determine whether he hits the bottle. Okay, so like all mechanics problems, drawing a diagram would help. So here we have Nathan here. We have a wall 12 metres away. On the top of the wall we have the bottle. He releases the ball 1.2 metres above the ground at an initial speed of 12 metres per second with an angle of 42 degrees to the horizontal. The wall is 3 metres, and we have to be careful here because we've got 20 centimetre tall bottle, so that will make it 0.2 metres. Okay, now having got the diagram, we need to consider the the horizontal motion and the vertical motion. And what we will need to determine is whether the vertical height, which we'll call y, is between 3 and 3.2. 3 and then 3.2. If it's between that, he will hit the bottle when we do the calculation. So if we consider horizontal motion first, for horizontal motion, the distance x, this distance is given by ut cos theta. So we're going to have that 12 is equal to u, which is 12 cos 42 times t. So we're going to have 12t cos 42. T will be equal to, the 12s will cancel out, 1 over cos 42, or you can work that out if you want, but don't round it off when you put it into the next part. Now if we consider the vertical motion, the vertical motion y is given by ut sine theta minus a half gt squared plus 1.2. It's plus 1.2 because he releases it 1.2 metres above the ground. So putting that information in, we're going to have that y is going to be 12 sine 42. The t will be 1 over cos 42. So we'll need to divide this by cos 42 degrees. Minus a half times g times my value of t, which is 1 over cos 42, but we'll need to square that, and of course don't forget to add the 1.2. This becomes tan 42 minus a half g 1 over cos 42 squared plus 1.2. Just writing that out again. So calculating that using a calculator, making sure my calculator is in degree mode, will give an answer of 3.132 metres. And then that's not the answer. We need to actually determine, give some sort of reason. So this is between 3 metres and 3.2 metres. As we originally stated, this had to be between these two values. So the stone, in this case, does hit the bottle. Okay, this has been a video to show you whether a stone hits a bottle on a wall using projectile motion. I hope you've understood, and I thank you very much for watching.